Good morning, Year 9. So we're going to start a new topic, solving equations. So we have seen equations in our 20 questions, and I know it's something that some of you struggle with. So we're going to go back to basics. There are several different methods that we can look at for solving equations. I'm going to go through two today. Choose one that you understand. You don't have to all use the same method. That's absolutely fine. If you don't understand these two methods, then let me know and we can find something that you do understand. Okay, so first method we're going to look at is called the balancing method, and it's the one I tend to use when we're doing 20 questions. And it's the idea that an equation is like a balance. Okay, so everything on this left hand side balances with everything on the right hand side, and that's like on the equation, everything on the left hand side of the equal sign balances with everything on the right hand side. Okay, and as soon as I try and do something to this side, so take something off, okay, the equation becomes unbalanced, and that's what we're trying to avoid. We need to keep it balanced at all times. Okay, so for example, if I was trying to work out what one of these blue weights was worth, okay, I need to leave it so that I've got a blue weight on one side and all the yellow weights on the other side, so I can see what a blue weight is worth. So I'm going to start by just saying, well, I've got blue weights on both sides. I'm going to take blue weights off, but I can't just take one off this side because I can become unbalanced. I've got to take exactly the same off this side, so take a blue weight off here and we stay balanced. Okay, so I've taken a blue weight off both sides. Okay, now I've got no more blue weights here, so I'm going to have to take some yellow ones off, but as soon as I take one yellow off here, okay, I'm unbalanced, so I have to take a yellow off here. So I'll just keep going, one off here, keeping it balanced, one off here to keep it balanced, one off here to keep it balanced, and so on. Okay, till I get to the point where I've got the blue weight on its own here, and I can see that it's worth 5 of these yellow weights. Okay, so I've solved the equation. A blue is worth 5 yellows. So we're going to look at that in algebra. Okay, so we've got these questions. There's one other type we're going to look at in another lesson, but we're going to look at these first basic ones. Okay, so you could probably solve most of these straight off. Some you might struggle with, but you will know what the answer is without doing too much work. But what I want to focus on is technique, so that when we get to the harder ones, you've got some skills to use to solve the harder ones. So if we look at that first one, I know an x plus 4 equals 10. Okay, so I need to leave the x on its own, as it says up here. So I want to get rid of this 4, and if you remember, I'm going to take that 4 off. Okay, but I can't just take the 4 off this side because the equation becomes unbalanced. I've got to take the 4 off this side. Okay, which leaves me with, well, the x, I'm not taking anything away, so it stays. The 4 take away 4 leaves me with nothing, and the 10 take away 4 gives me 6. Okay, similarly with the next one, I've got x plus 6, so I want to take this 6 off. Okay, so 6 off both sides. Okay, so I've got x take away nothing gives me x. The 6 take away the 6 cancels, and I've got the 45 take away 6, which is 39. Okay, last one. Okay, I've got the x on its own and I'm adding 2, so I want to get rid of the 2, so I take 2 off, take 2 off here. I've got to do the same, which leaves me with x on this side equals 21. Okay, so that's if I've got an x add something. If I've got x subtract something, okay, I've got to think about how would I get from -9 back to 0. Well, you would have to add 9 in this case, but again, I can't just add to this side. I need to add to this side, okay, which gives me x equals 2 add 9 is 11. Okay, so the -9 and the 9 give me 0, and the x add nothing gives me x. Okay, similarly here, I've got a -3, so I need to add 3 here, but I need to do it to both sides. Okay, so I've got x add nothing gives me x, the minus 3 and the 3 cancel out, and the 4.5, sorry, plus 3 is 7.5. And the last one on this one, same idea. I'm going to add 5 to get this to 0, but I need to do it to both sides. Okay, so I've got x left here, and 0 at 5 is 5. Okay, these are slightly different. So here I've got 4 of something equals 12. Okay, so to work out what one of those is, I've got to divide this up into 4. Okay, so I'm going to write that as a fraction for this one. But again, if I'm dividing this up into 4, I've got to divide this up into 4. So we get x equals 12 divided by 4, which is 3. Okay, here I've got 6x equals 17. So I need to divide this into 6 parts to find out what 1x is. So I'm going to divide by 6. So I need to do exactly the same to the side. Get 17 divided by 6. Now, if you know your 6 times table, you know 6 doesn't go into 17. That's okay. I can leave my answer as 17/6. Okay, don't need to type it in a calculator. If you want to work that out as a top-heavy fraction, as a mixed number, you can, but you can leave it as a top-heavy fraction. That is an acceptable answer. X is 17/6. You don't need to do any more, which is why this dividing at this stage is so important. Last one, I need to divide this up into 7 parts. Okay, and 63 also needs to be divided into 7 parts. So that gives me x equals 9. Okay, so we've been through the balancing method there. If you understand that and you are happy with that method, then feel free just to skip the next page and the next section of the video and go on to the practice questions and then on to the exercise. For those of you who just want a different method to look at, we're going to look at what's known as a bar modelling method, okay, which involves drawing pictures. So what I want to show you here is how we would set the pictures up. Okay, so it says here that I've got x plus 4. So this purple block is my x, and this yellow block is my 4, and x plus 4 together is worth 10. So it's this whole bar here is worth 10. Okay, so what I should be able to see is that I can take this 4 off here, and when I take that 4 off, what's left over here is 6. So this becomes a bar of 6 and 4 instead of 10. Okay, do that again. So this bit's 4, and because I know it has to add up to 10, let's do it this way, like that. Okay, I know this bar must be 6, and this is the same size as x, so x must be 6. Okay, similarly here, I've got x plus 6, so I've got x here and 6 here, and I know this bar here is worth 45, so I know this bit here, if I cut it at the same place, is worth 6, but I know the bar has to add up to 45. So I have to take 45 and something plus 6 must be 45. That's going to be 39. Okay, and the last one, we've got x plus 2. And I know that this bar is equal to 23. Okay, so I've got the 2 goes here. 2 plus what gives me 23? Well, it's going to be 21. Okay, so that's the adding ones. The subtraction ones we need to think a little bit more about. So this purple bar is still my x. But what the sum says is I start with x and I take 9 off. So this sort of gap here is worth 9 because I started with x, I took 9 off, and the answer was 2. Okay, so I can see from this that the 2 and the 9 together must give me x, so x is 11. Okay, similarly here, okay, I've got this is my x, I've taken off 3, okay, and I was left with 4.5. Okay, So then I can see that x is worth 4.5 plus 3, so x is 7.5. Okay, last one's slightly trickier. So again, I've taken x, all right, I took off 5 and then I was left with 0. So therefore this section must be 5, so x must be worth 5. Okay, so last ones to think about. Okay, so this said 4x equals 12, so what I've got is 4 bars together, and I know this whole bar adds up to 12. So what I'm going to do is I'm going to split that bar into 4 parts. So I know 12 needs to be split into 4 parts, and each part must be worth 3, therefore x is worth 3. Same idea here, I had 17. I'm going to split it into 6 parts. So it tells me that I've got to be doing 17 divided by 6. As we said before, we can't do 17 divided by 6 and get a whole number answer, so we can just leave our answer as 17 over 6. And the last one we've got is 7x equals 63. So this whole bar here is 63, but I need to divide it into 7 parts. Okay, so I need to work out how many 7s go into 63. Okay, which will be 9. Okay. So I've got a few questions for you to have a go at there. Use whichever method you prefer for that one. You don't have to stick with the same method for the harder ones. Just be aware of this last one, okay? I've put a little star there. Be really careful how you do that one. It's slightly trickier than the ones that we've looked at. So hopefully you've paused and we'll do some answers quickly. So on this one we were subtracting 5 from both sides. Okay, and you got x equals 6. On this one we were dividing by 2. So you've got x is 13 over 2, or you may have worked out that 6.5 or 6.5, doesn't matter. Okay, and on this one we've got, we're adding 9. So we get x equals 11. So the next ones I've done using the bar modelling. So we've got, this is x, this is a half, and the total is 6, okay, from there to there. So if I want to take that, I know that bit there is worth a half, so a half plus something is 6, so that must be 5.5, so x is 5.5. Okay, the next one we've got 3 x's are equal to 21. Okay, so if I divide that up, I need to do 21 divided by 3, gives me each one is worth 7, so x is 7. And the last one we did x, so this is the x, we subtracted 6, so that little gap there is 6, and we were left with 42. Okay, so to find the value of x, I need to know, do that again, this bit here is 6. To find the value of x, I need to do 42, add that 6 on there, and that gives me 48. Okay, so the last one's slightly harder. So I'm going to start with 10. So I know that bar is worth 10 because that was my starting point. Okay, we'll write that in. So this bar is worth 10. And I know I took x off and I was left with 7. So this bar here is worth 7. Okay. So I've got 2 bars, one was 10, one is 7. How did I get from 10 to 7? Well, I took x off. So this bit here is x. Okay, so we need to work out, if I started with 10 and ended up 7, what did I take off? Well, I took off 3, so x must have been 3. Okay, so have a go at this one. No. Okay, so we've done the sort of basics. We're going to now move on to what we know as two-step equations. And in these ones, we're trying to get x on its own. So I've got 3x plus 2 equals 23. So on the left-hand side, I'm going to do the balancing method. On the right-hand side, we're going to look at the bar modelling method. Okay, so starting with this one, I've got 3x plus 2 equals 23. Now, when we're following this, we're used to following BIDMAS, but when we're solving equations, we do BIDMAS backwards. Okay, so I'm looking for subtractions. There are no subtractions. Then I would look for an addition. Well, I've got an add 2, so that's what I'm going to deal with first. I need to get rid of that add 2. And as we said before, how do we get rid of add 2? Well, we need to get to 0. We would subtract 2. But again, I can't do that on the left-hand side without doing it on the right-hand side, otherwise we won't balance. So I've got 3x take away nothing is going to give me 3x. 2 take away 2 is going to give me nothing. And 23 take away 2 is 21. So now I know 3x is 21. I need to divide those 3x's into 3 to find out 1x. But again, I need to do exactly the same to the other side. I need to do 21 divided by 3, which should give me x equals 7. Okay, so that's the balancing method. If we were going to use the bar modelling, so my picture would be 3 x's, so each of these purple bars are worth x. Okay, and then I would add 2 on the end, so there's my 2, and I know that equals 23, so that whole bar there is worth 23. So I'm going to start by saying, well, if I know that bit's worth 2, then I know this bit here is worth 2, so this bit here must be worth 21. So I can now see that 3x's are worth 21. But again, I want to find 1x. If I divide this up into 3 sections, okay, I need to do 21 shared between 3 to work out that each section is 7. Okay? Okay, let's have a look at another question. Number 2, this one we've got is 2x minus 5 equals 9. So again, we're following BIDMAS backwards. I'm going to deal with the subtraction first. How do I get minus 5 to 0? Well, I would add 5, okay, which is doing the opposite. But I can't just add 5 to this side. I have to add 5 to that side to keep it balanced. So 2x plus nothing is 2x. Minus 5 add 5 is nothing, and 9 add 5 is 14. And then I need to divide, I've got 2 x's here, so I need to divide that into 2 parts to find out 1x. And same, I have to do exactly the same to the other side. So I need to do 14 divided by 2, which should give me x equals 7. So if we come to our picture here, so we started with 2x, there's my 2x, but I took 5 off to get the answer 9. So by taking 5 off, I know that this gap here is worth 5. Okay, because 2x back 5 gave me 9. So now I can see that the whole length here is 9 plus 5, so the whole length must be 14. Okay, oops. So, okay, I know this whole length here is 14. If I divide that into 2, I get each part is 7. Okay, so whatever method you prefer, I don't mind. I'm just trying to find different ways to explain the same thing. So I've got a question here, pause. Use one of the methods to see if you can work that one out. It's slightly harder than the ones we've looked at, but it's worth thinking about. Okay, so let's have a look then. So 6x plus 3 equals 6. I need to start by getting rid of the 3. Okay, which gives me 6x equals 3. 6x take away nothing is 6x. 3 take away 3 is nothing. And 6 take away 3 is 3. Okay. Now, I've got 6 x's, so I need to share those out. Divide that into 6 parts, okay, to find 1x. But if I'm dividing this by 6, I've got to divide this by 6. Now, 3 divided by 6, the answer is not 2, okay? What we've got here is a fraction which is 3/6, and 3/6 will cancel to a half. So the answer is x equals a half. Okay, if you did it using the bar modelling, you should have had a picture where you had 6 x's, add a bit more, which is 3. Okay, so let's write that in there, that's 3, and each of these are x's, and so on, and the total of that was 6. So that adds up to 6. So again, we start by saying, well, I know that section's 3, so that section there must be 3, and that section there must be 3, because 3 add 3 is 6. Don't worry that it's not to scale, that's fine. It's just a picture to show us what's going on. So now I've got 6 x's, so 6 of something add up to 3. Okay, so you can do what we did over here and say, well, I know I've got to divide by 6, so you could do 3 divided by 6 and work out that x is going to be a half, okay? Or you might say, okay, well, this is worth 3, let me split this into 3, and then I know each one is worth 1, and then I can see 2 x's are going to give me 1, so I can see that x is a half. Okay, either way it doesn't matter, but your answer for that should be x equals a half. So again, pause and have a go at this one. Move that up there. 4x minus 3 equals 17. So what you should have is that you're adding 3 to both sides. Okay, which gives you 4x equals 20. And then you need to divide this by 4 because you need to find 1x. You need to divide it into 4 parts. So divide 20 by 4 as well, and you should have x equals 5. Okay, if we're doing the bar modelling, we'd start with the 4 x's, okay, but it says I have to take away 3 to get 17, so 17 is smaller. So the 17 bar is there. It's smaller than the 4x, and I know it's 3 smaller, so I know this gap here is 3. So that tells me that the whole length here is 20, because 17 add 3 is 20. So I want to do dividing the 20 into 4 parts, and 20 divided by 4 gives me 5. Okay, so again, I don't mind which method you use. Choose a method and have a go at these questions. Okay, if you've pressed pause and tried those, these are the answers. If you're not sure why you were getting some wrong, just have a look back, make sure you're following the rules. If you're still not sure, then email me and I will try and go through it with you. Okay, but they're the answers. Okay, have a good rest of the day.